So let me actually start. We use these 2 minutes. There's no reason why I have to go in the wrong order. So I can use this just to point out the beginning about this workshop. I want basically say that this has been a real support by the several people on the physics division. Start with us that were interested in the interface of physics and biology, but actually grew up to a lot of other people in physics interested in machine learning. And myself and Herb start. Then we recruit Juhai that did the heavy work for this workshop. So we want to thank him for doing that. And as you can see below, there are a lot of people in NSF that help us on this in all the ways. So also in a sense, it's basically the NSF is funding this workshop, and we are the 3 organizers, but we got a lot of input from these people from the NSF that help us to put there. And I have the names there: Creston, Slava, Jim, and Angel Garcia. So they have been here. I think Angel is probably on Zoom, not in present, but the other people, Jim and Slava, are here, and they really help us with this thing. So I just have on this front slide, I just want to use a couple things, is that people come from our end, what we try to do, and I don't want to go into our modeling techniques because we have lots of them, but I want to say that one thing we're very interesting, here's our work on chromosome structure prediction, and you see that a big part of it is we don't do machine learning alone, we do that together with a lot of physical modeling. So it's the combination of physical modeling and machine learning has been, in our way, as a user of machine learning, a developer of machine learning, has been something we are interested. And I think we're going to have a lot of that for every area during this workshop. So just to present the way, oh, I have to click here. Why is this not moving? Okay, now move. We had a lot of discussions on how to run this workshop. And you can see the first part is just basically how artificial intelligence is changing science, right? And I put in engineering here in general. So this is more an application part of machine learning. So we decided to go in that order. We thought it would be a nicer way of motivating everybody. People can argue with us if we should do the opposite way, but decided to go in the order. And the first part is on general physics applications. The second part is on biological physics applications. Actually, the schedule changed a little bit, so I apologize for that because the weather at Dulles forced us to do a minor change on the schedule. And in the middle of it, we are going to have a talk by Dave Baker talking about the entire idea of protein designing using deep learning, okay? The second part of the talk, then we go to more to what you call the fundamental parts of AI, and we try to go to 2 perspectives of it. One that people that come from computer science, how they have been seeing AI, and then we have the people coming from, I'll call mathematics and physics, they have this statistical physics description. And then we hope to conclude with figuring out where we go on the future. And you don't see Creston coming, do you? Okay, so I think that with that in line, I think the good thing now is I would like to say that over the years, this sort of working at the interface of multiple sciences, bringing physics with the other sciences and how physics can grow, we have had Denise Caldwell, who I know for a long time has been now is the director of the physics division, that has very, very interest on this idea to make sure that the entire directorate, the entire division is not static, but actually see all the other possibilities, how physics can expand. And I think this workshop represents one of these things, and I think that's one of the ways that has been very positive. And I think a lot of the things we did, in my personal case, has been on the interface of physics and biology, but you have the interface of physics with materials, the entire development on growing atomic physics in many other areas has been on this sort of very open view of Denise, of look at the future, and a lot of new things that came from the NSF. So with that said, I will let Denise say a few words, please.
Okay, well, thank you very much, José. I don't know if you want to maybe stop sharing the slide. People can possibly see me better. I had hoped to be at the workshop in person, but I had to leave the DC area a week earlier than I had originally planned. Certainly, I would like to say on behalf of the physics division that I think this workshop and what we hear from this workshop is going to be extremely important as we start to move ahead within the division. We have already seen within essentially virtually every program in the division, the POLS program, the elementary particle physics program, the experimental program that Jim Shank is managing. We see it in the gravitational physics program, the plasma physics program, the increasing, I would say, growth, but also value of machine learning and AI techniques to advancing the science that we ultimately want to advance. And I only see this growing in the coming years, I would say. And so for us to be able to recognize and pinpoint certain areas where we really see the potential for the use of AI and machine learning, again, to advance the science. But also, as José mentioned a little bit, and I think it's true for all of these activities that we do jointly together, is that it doesn't just advance physics, it also advances AI. But so we think about it as AI advancing physics and physics advancing AI. So it's, I mean, I think that I don't know what more I can say, except to say that this will certainly, from everything I've seen through our proposals and through how we're seeing the community move, I think we're really, really looking ahead to an important new direction in the future for the science that the division supports. And any advice or sense of direction you can give coming out of the workshop will be very valuable as we take the next steps. I hope this for you is a successful workshop, and then you get out what you want to get out of it. I think that's essentially what I would like to say. But I'm open to any questions anybody would like to ask if we have a few minutes for questions.
Do we have any questions, any comments people want to make?
I think it's probably on everybody's mind here that whether NSF would have a sort of establish some new initiative in this direction in combining AI with. I think there's a lot of program already going on, but is there any intention to actually make this workshop as a sort of exploratory things to look into new directions? For example, in using physics method to understand how AI works, would that be a plausible future direction for NSF to explore?
Yeah, these are the kinds of things that we're asking you to tell us, right? I mean, this is the purpose of the workshop, for us to get community input so that we can identify those areas where we see there's a real need and a real opportunity. I mean, for example, that we have an institute, one of the AI institutes that was created, a couple of years ago with the first foundation, or with the foundation of the first AI Institute from MIT. And that grew out of the solicitation for those AI institutes. And a part of that solicitation that was specifically directed toward AI for the benefit of physics. So what we look from the workshop is for you to point us in directions where you see both need and opportunity. This is essentially how we use the workshops. So I can't say definitely that this will happen or that will happen or something else will happen. I would say that one thing is true, that we do build our programs and our emphasis areas as we move ahead from just such workshops as these. So if there is, a strong justification for what you suggest, then we will certainly listen to it. We will also continue to try to work together. Physics, I've been in the physics division for many, many years. And one of the things that I've certainly always done, and as division director for the physics division, is to really stress the value of working across all of the areas of science and engineering that the NSF funds. So the physics division, through the activities of our program directors, has multiple connections across NSF, including the SCIES Directorate, where AI is a lot of the AI work is being developed, the engineering directorate, the bio directorate, which I'm sure will be very interested in what comes out of this particular workshop. So not only working for physics, but are there ways that we can work with other parts of NSF to move the both the applications and specifically the science forward. It's always been my contention that if you read the act that created the NSF was created to promote the progress of science. And that is the overriding principle. And as long as we adhere to that and don't forget that, I think we're in a good position to do exactly that. So does that help? I'm not going to promise any one particular thing, but we're going to listen to you.
Okay, that helps a lot. I think it was a great comment. Let me present my humble summary of it. Denise is telling us, present the best possible future science. Present all the excitement, how the management and new programs, stuff like that. We have enough program directors that will do that. If you come with a good story, they worry about the other side. So our job here is not to worry about new programs or new things. Just come, what's the exciting science you'll see in the future and what we should be doing. If this positive thing come out, that will help everything. Do we have any other question? If not, I want Preston to say a few words.
Hi. Okay, I didn't expect that. Well, thank you for coming, and it's I think it will be a great workshop. 20 years ago, I was member of the Los Alamos group on machine learning. We were trying to discriminate. In fact, I was hired in Los Alamos on a big internal grant on machine learning and big data analysis. And we were trying to discriminate between lightnings and nuclear explosions. And the field was nowhere where it is now. And it's all thanks to you. Probably most of you were not at that time working on these problems. But I learned. I tried to read books on support vector machines and non-linear kernel methods and so far and so forth. For a physicist, minimization procedures, optimization are not new. As you know, after calculus was invented by Leibniz and Newton, calculus was extremely successful in reformulating physics in terms of Hamiltonian and Lagrangian methods. I suspect that machine learning will reformulate a lot of science. I don't think this is new science, but it's going to reformulate science in very different terms. And so you're the ones that are going to do it. And thank you so much for coming.
So I think that with that said, Denise, do you have anything else you want to say?
No, except just to wish you a very informative and successful meeting. And we're very much looking forward to what you have to tell us.
Okay, thank you very much for joining us so early. Particularly, you are an hour earlier. So anyway, so thank you.
Mm-hmm. Thank you. So I'm going to go because I'm going to my next Zoom meeting.
So with that said, let the festivities start. Slava is going to start the first section.